Hey guys, welcome back to SUNA Academy. If you are new here, myself Karthikeya. I'll be teaching you concepts of physics that are related to JEE Mains, JEE Advanced, NEET, UG and many physics Olympiads that will be coming across in grades 8, 9 and 10. So if you haven't subscribed to our channel, do subscribe to our channel, hit the bell icon right beside it and do like our videos and share our videos to your friends and your fellow aspirants. So as I have said that I'll be discussing some applications on component of vectors in my last video. So we'll be getting into the video now. So the first application that I want to come across is if you have a block of mass m, okay, on a smooth horizontal plane, and if you have got some force F acting on it, and this force F is actually making some angle theta with your horizontal. Okay, now if I'll be asked to find the acceleration of the block along a smooth horizontal plane, that is along x-axis. Okay, as you know, in two-dimensional plane, this is nothing but your x-axis, and the direction which is above, that will be your y-axis, right? So if I'll be asked to find the acceleration of block along x-axis, then how will I be finding that out? So now at this point I'll be start resolving the vectors, the component of this force. So your force in along horizontal, the component of force along horizontal is F cos theta, and the component of force along the vertical is F sin theta, right? Okay, so your acceleration is nothing but force by mass, and your force in the horizontal component of your force is nothing but F cos theta by m. Okay, so this is where you come across the resolution of vectors, okay, in different directions. So now we'll be looking at the second application. So if I'll be having an inclined plane, and I have a block of mass m placed on it, okay, mass m, okay, and if this is smooth, your block will be sliding down the inclined plane, and now he'll be asking you what is the component of weight, or what is the component of force that is actually driving it downward. Okay, so if you have left your body a block of mass m directly downward, and this is why the force mg which is acting downward, the weight of the block is why it is drive down. Okay, so along this, what is that force, no, what is that weight, component of weight which is actually driving that down the inclined plane is what you have asked. Okay, so generally your block weight mg will be directly downward, okay, towards the horizontal plane. Okay, and the angle of incline is theta. Then if you are asked to find what is this component of weight, then you're now going to use the component resolution of vectors. Okay, so let us get into the depth of the diagram. Okay, if this is your theta, if I'll be drawing a perpendicular to your inclined plane, if this is your theta, this will be your 90 minus theta. If this was your 90 minus theta, and this will be your theta. So this will be, if this was your 90 minus theta, then this will also be 90 minus theta. So this angle will be theta. Okay, from simple angles that you have learned in grades 8 or 7. Okay, so if this was the case, let me take a incline. Okay, and if this is your block of mass m, and if this is your theta, and weight of this is actually acting downward mg, and the perpendicular to incline, and this will be your theta. Since this was 90 minus theta, this will be 90 minus theta, and this will be your 90, so this will be your theta. So if this is your theta, and then this angle also will be your theta, right? Okay, so this component of weight will be mg cos theta, right? So if this is your theta and this is your mg, and this will be your mg cos theta, and along the incline this will be your mg sin theta. So mg sin theta is the component of weight, which is why your block of mass m is actually driving down the inclined plane, which is smooth. Okay, now let us also look into another different application. So if I have a bob actually which is actually hanging vertically downward, okay, and this has got some mass m, and if this has got some length L, okay, and if that bob is made to stand here with some force right here with F, and this is an mg acting downward, okay, and tension in that string is some t. Okay, now if I'm being asked to find that f in terms of this angle theta or some known terms of ball of mass m or length L, okay, how will be finding out? So if this is a t, then you can also resolve your tension components. Then this will be your angle theta. If this was theta, and this will be your angle theta. So this component of tension is nothing but t cos theta, and this component of tension is nothing but t sin theta. So just equate the forces in along y-axis and x-axis. Okay, so your F is nothing but t sin theta, right? And your mg is nothing but t cos theta. So just divide the equation 1 and equation 2. So your F by mg is nothing but t sin theta by t cos theta. That will be your t tan theta. Sorry, tan theta. So your t gets cancelled. So your F force, the value of F is nothing but mg into tan theta. So even in this case, we have actually seen how we resolve our tension and find the value of F that we have been asked. Hey guys, if you haven't liked our video, do like our video to encourage and support us. So the next subtopic we'll be looking across is the directional cosets. Okay, so if I'll be considering the 3D Cartesian coordinates x, y and z. Okay, if I have a vector starting from origin to some point P, okay, and let's say it has got some point x comma y comma z. So x comma y comma z means if this p bar is actually projected to x-axis, then this point will be x comma 0 comma 0. Okay, and if it is projected to y-axis, okay, so this is actually known to you in simple 2D plane, right? So if this is some point P and this represents some x comma y, okay, and along x-axis, this you can say that this is x units, and along you can say this is x, so this is x units, so this can be x comma 0, and if this is x comma y, you can say this is y units, so this can be 0 comma. So similar case, now we'll be looking across in a 3D plane. Okay, 3D coordinate system. So and that same projection on z axis will be 0 comma 0 comma z. Okay, same projection on y axis can be 0 comma y comma 0. Okay, so if this vector is actually making some angle alpha, okay, alpha with your x-axis, okay, and angle beta with your y-axis, and some angle gamma with your z-axis. Okay, what does actually directional cosine mean? Okay, DC. Okay, it is simply also known as DC. Okay, but directional cosine says that cos alpha and cos beta. Okay, so these are generally your directional cosines. Okay, cos alpha, cos beta, and cos gamma. So what is your cos alpha? From some simple trigonometric, you can see that your cos alpha is nothing but, okay, now I'll also show you. Okay, if this is your if I'll be considering in xy plane, okay, in xy plane, in simple xy plane, this is your y and this is your x, right, and this is your length L. Okay, the length of vector, the vector length is L. Okay, let us try to find what is that L. Okay, so it is the simple distance between origin and point P. How can you find the distance between 2 points? Okay, it's from simple distance formula. So your L or D, distance between origin and that point, is nothing but root over x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is a simple distance formula from your maths. Okay, so that will be x minus 0 whole square. Since you are trying to find the distance from origin, this is your origin and this is your point P. So this is your x square plus your y square plus your z square. Okay, so let us say it L for some time being. Okay, your cos alpha will be simply adjacent side by hypotenuse, so x by L, and your cos beta will be, cos beta is nothing but this, and that will be adjacent side by hypotenuse, and your adjacent side is y, right? So it will be y by L, and cos gamma will be your adjacent side. In when you are trying to find cos gamma, you take it in y z or xz plane, and then that will be appearing for you like if this is your z axis. Okay, if this is your z axis and if this is your x axis, then that will be appearing for you as this to be your z units, right? Okay, and this is your gamma, then your cos gamma is nothing but simply z by l. Okay, so now we have derived the directional cosines cos alpha, cos beta, and cos gamma, and now we have a property of these, that cos square alpha plus cos square beta plus cos square gamma is equal to 1. Okay, let us see how. Okay, so your cos alpha is nothing but x by l, right? So x by l whole square plus y by l whole square plus z by l whole square is equal to 1, right? Okay, and what is your x square? X by l square, x square, since your denominator is same for all your l square, so x square plus y square plus z square, right, is equal to 1. So what is your l square? Your l square is nothing but x square plus y square plus z square, so this will be x square plus y square plus z square, right? So now we have proved that this is 1. So this is a property that sum of squares of directional cosines is 1. Okay, cos square alpha plus cos square beta plus cos square gamma is 1, and these directional cosines cos alpha, cos beta, and cos gamma are also known as the L simply in some math. Okay, in some math problems it also depends L, M, and N. Okay, respectively L, M, and N. Okay, now sometimes you'll be also be asked this question: what is the value of sum of squares of sine alpha, sine beta, and sine gamma? Okay, so you can do this like cos square alpha can be written as 1 minus sine square alpha, right? And your cos square beta can be written as 1 minus sine square beta, and your cos square gamma can be written as 1 minus sine square gamma is 1. So I'll be pulling out all this to my right hand side, and I'll be pulling out this 1 to my LHS. So 3 minus 1 is 2, right? So 2 is nothing but your sine square alpha plus your sine square beta plus your sine square gamma. Okay, so this is nothing but the sum of squares of sine alpha, sine beta, and sine gamma. And now we have completed the subtopic directional cosines. Hey guys, I'll be catching you up in my next video with some more subtopics of vectors. If you haven't subscribed to our channel, do subscribe to our channel, and don't forget to hit the bell icon right beside. Thank you.